are you live or work in Rookie? Okay, so it's about half of you, maybe a little bit more. All right. So I can go ahead and assume that the rest of you are visiting from elsewhere in India. And I know there's one person from Trento. Who's from Trento, Italia? Buongiorno. All right. I love Italy. We'll worry about that later. So, first of all, why is Rookie just a great place to have a stormwater workshop, right? And well, first of all, Rookie prides itself as being a clean city and a green city. All right. Then on top of that, it's also a smart city. So guess what stormwater management is? It's clean, it's green, and it's smart. It's true. I couldn't have made this up any better. All right. So Rookie is a great place for us to be doing a week-long course in stormwater management. I want to share with you a little bit about me. You'll be seeing me for 5 days, so you might as well know a little bit more about me. First of all, I'm the father of 5 children. You'll see them in the upper picture there. Where's my man Charles? You're in here somewhere. There you are. This one in front of me, that's my Charles. I just like it when he gets his hair cut. His hair is a little too long for me, for my taste, and it's fine. But that's Charles. That's Bill, Joseph, Charlie, Claire, and Annie. And this guy up here, he especially likes Annie. All right. And then over here, this is my research team. And a lot of the work, it's important I point them out and their predecessors out because so much of what I'm going to share with you is actually done by them, all right, or people that came before them. In fact, anytime you go see a lecture by a professor and he or she is up there telling you about it's always been done, not that we're void of it, we are a part of it, but the hardest work is usually done by someone like these folks in the picture. So I'm very indebted to them. And so that's my research family back home. North Carolina is very famous for lighthouses. You can see one in this picture right there. It's a beautiful lighthouse. In fact, the tallest brick lighthouse in the world is in North Carolina. Now you might be wondering a little bit more. So I love sport. How many of you by show of hands like sports? Great. Only half of you. All right, that's fine. Now, America, I know, has like maybe the most unique sports in the world. Maybe I'm wrong, but we have baseball. We love baseball. That's my favorite sport. Basketball and American football, which is different from the rest of the world's football. Now, I have come to see cricket and see cricket. How many like cricket? Oh, well, you'd love baseball. You'd love baseball. Baseball and cricket are related. You have a big stick and you hit balls with them. All right. Professor Oja actually did a nice job of introducing me, so I'm not going to go into my background, but I do a lot of workshops. And it's one of my favorite parts of my job, actually. Most of them are in North Carolina, but India now makes the 11th country that I've been able to give a workshop, a multi-day workshop in. So I'm really excited about that. And it's a real honor to be here. So next time I give this talk, I'm going to add India right there, right in front of Jordan. And I also love historical engineering. How many of you like history? That's good. I wish more engineers liked history. I really do, because it would enable us to have a better understanding of the technological revolution that we're going through. I talk with my hands, so it's going to be interesting to see if the shawl can make it. Is it really bad if I drop the shawl by accident? No, it is bad. I can look at your face and see. Don't drop the shawl, huh? That's what you're trying to say. Okay. And and I focus mostly on Roman infrastructure, aqueducts, theaters, roads, but I like all old infrastructure, especially water infrastructure. And when I came to visit India the first time, we made a point to go to the step well. Oh man, it's awesome. But you know what they wouldn't let me do? Go down any of the steps. That was a bummer. But they wouldn't let me do that in America either because they'd say it's unsafe. But anyway, I went to the step well and I loved it. Most people, when they come to India, what do you think they want to see? What's the one thing people come to India from America? What do they want to see? It's a building and it's a love building. The Taj Mahal. Yeah. But when you send a water engineer to India, what does he want to see? A step well. I'm going to make you guys laugh before it's all over. Anyway, it is great to be back in India. My very first time here was just last year, in February into March at the Water Conclave. I enjoyed it very much, which is really why I'm back. And so much, and the reason I was able to come last time was in great part due to this dude right here. That's Dr. Sujit Eka, and he got his PhD with me, and he has several friends right here at IIT Roorkee. And so it was great. And this is another, I don't know where Deb went to school, but Deb Sahu is a professor at Clemson University. He also is from India, and we had a great time. This is up in Haridwar. I'm sure y'all probably knew that. But we had a great time up here. So it is wonderful to be back. Now, I want y'all to know a little bit about my state. I'm very proud of North Carolina. It's a beautiful state. So first of all, here it is. If you want to know where Donald Trump lives right up there. He also lives right down here. He actually has lots of houses. Okay, but North Carolina is right in between in the south. Okay, and my particular city is right there. All right, North Carolina is a beautiful state, and we have beautiful beaches. Okay, you can see some of my children when they're younger there, and we also have mountains. When I say mountains, I'm not talking like the Himalayas. All right, those are mountains. Mountains. Our mountains are much lower, about 2,000, 2,500 meters. Okay, but we have these beautiful mountains with, guess what? Beautiful waterfalls. All right, so I love waterfalls. So I love ancient stuff and I love nature stuff. All right, and I love water across the board. The most important thing that ever happened in North Carolina, how many of you have been on an airplane? Yes, I know the answer. I figured the two gentlemen from Africa, you've been on an airplane. Otherwise, it's a very long drive, a very, very long drive. But the most important thing that ever happened in North Carolina was the Wright brothers. The first flight was in North Carolina. And even to this day, for me, I feel very special. It's a very special feeling when I go and I see the site where the first flight occurred. Now, I'm not going to talk any more about it, but understand that prior to this time, heavier than air flight was viewed by most people, not everybody, but most people, as impossible. But in fact, it was not impossible. It was very much possible. We just had to unlock the knowledge and with a lot of engineering and effort to make it happen. All right. So remember that for the rest of this week. Okay. That we're going to talk about technologies. And some of you might be thinking, I don't know if we can. There's going to be some place where you will unlock enough of the requirements that you'll be able to trial these things out. All right, so just remember that. I'm informed by my history, including the Wright brothers in the first flight. So what's Raleigh like compared to Roorkee? Well, it's a little further north. It is a little cooler. The weather today, which is lovely, is very similar to the weather that we would have in September, about a month ago in Raleigh. We have approximately the same amount of rainfall, but I think yours falls in a 5-month window? How many months a year does it rain in Roorkee? I hear 4? 4 months. It rains every month in North Carolina. All right. But some months it does rain more. And you know what those months are? It's the months where we get hit by hurricanes. You might know them as typhoons. All right. So North Carolina, you see, kind of sticks out right over here. North Carolina gets hit by a lot of hurricanes. All right. And so, in fact, we have one. It doesn't have a lot of wind right now, but we have one that's dumping a lot of rain. I think probably about 300 millimeters of rain are going to fall in Wilmington, actually. All right. And so we get a lot of rain due to these systems, but it rains all year long. But that is why we worry about stormwater as much as we do in North Carolina. All right. Now, what I want to talk about is gray infrastructure versus green infrastructure. How many of you have heard the term green infrastructure. All right, that's good. Now, the next time somebody asks you this, everyone can raise your hand because you know everyone's always asking, have you ever heard of green infrastructure? So, what exactly is it? I will show you some examples of gray infrastructure. All right. And it's really the infrastructure that we have had in urban areas for as long as we've had developed urban areas. All right. Places for people to park, ways for water to be conveyed. Whoops. Let me go back. Uh-oh, wait a second. Wait a second. Okay, good. I wanted to make sure I had a picture of Rookie specifically. How we channel rooftop drainage. All right. That would be considered gray infrastructure. Pipes that go to creeks, gray infrastructure. Do we have gray infrastructure in India? Oh, yes, we do. A lot of it, right? As does everywhere where we have a lot of people. But nowhere has more people than India. All right. In fact, this morning, my buddy Sean and I were on a walk through the beautiful campus of IIT Roorkee. How many of you like to take walks on the campus in the morning? It's lovely, isn't it? You can see a lot of birds. I like the birds and the cool looking squirrels you have. All right, so we were walking through Roorkee, went into the Thompson building, all right, looked at all the distinguished scholars and athletes and their names are on the plaques, the wooden plaques in there, and we walked through and guess what I saw? Gray infrastructure, pipes, all right, carrying water, channels to carry water, all right? So if you're from an urban area, an urbanized area, you're going to have a lot of gray infrastructure all over the globe. This is a British style channel that you see. I call it tropical British style. You don't see our swales in America look like this, but you go to Hong Kong, go to Singapore, a lot of water conveyance. That's all gray infrastructure. It's all good. Here's Singapore. How many of you ever seen a river like that? How many of you like watching movies? There you go. How many of you have ever watched Terminator? I'll be back. Do you remember the scene when the Terminator is on his motorcycle? Yeah? You remember him driving through? That's a river. It really is. It's a river. It's called the LA River, the Los Angeles River. Well, Los Angeles is not the only place that has concrete rivers. All right. And here's one gray infrastructure. It's designed essentially to carry big flows. All right. Here's one in Singapore. Next time I show this, I'm going to put a picture of Arnold in there because you guys will like that more. And then even things like reservoirs. Not all gray infrastructure is like, whatever. This is pretty cool stuff. A massive reservoir in a city that the Singaporeans built because of water supply. This is the reservoir near where I live in the United States. Many places in the actually east and west, all over, our water sources come from these very large reservoirs. If you look right over here, that's where my kids and I like to go swimming in the summer. Okay. Now, as I mentioned, gray infrastructure, it's been around for a long time. All right. But we also have newer forms of gray infrastructure, even though this one you might probably call yellow infrastructure. It's the idea of putting and storing water below ground, all right, mostly in an effort to reduce flooding. And to be honest, this stuff is not terribly difficult to design. You just have to know inflows, desired outflows, and know how much space you've got. And then you can figure out how many big concrete boxes you have to design. All right. What the volume of those boxes is. And so just know that. But this is a new form of gray infrastructure. And one of the big things that we started doing and debating, and some of them have been built in the United States, are these ginormous tunnels where when it really rains hard, they will store their water and then have it get slowly released or pumped out. Do y'all see the size of these people here? All right. And here is the tunnel bore, these massive tunnels. Now, is that effective from storing water standpoint? Sure it is. But what is it also? It's also very expensive. Okay? Very expensive. And other than storing water in these tunnels, what other purpose do these tunnels have? There really isn't any. All right. So in American English, we call them one trick ponies. Y'all ever heard that term before? That's a one trick pony. It means it can only do one thing. And that one thing in this case is to store water from big storms. Okay. So let's talk a little bit now about what the use of gray infrastructure, all right, means to the environment. Well, gray infrastructure is very good at taking water that's local and moving it quickly away. All right, it's very good at that, and sometimes that's exactly what you need. Gray infrastructure maintenance tends to be very straightforward. I was speaking during our high tea, and thank you so much for the high tea. In fact, those of you who are not from India, don't you just love masala tea? It's great. And I don't know why we don't have this in America, but we don't, do we, Sean? Oh, thank you for backing me up there. I love this stuff. Mm, it's better here. All right. Where's it going about the tea? Okay. So, oh yeah, during the high tea, we were talking that one of the big issues you have with your gray infrastructure is making sure it doesn't get blocked before the monsoons start. Right? I get it. And it tends to be a very straightforward maintenance. The monsoon season's coming. You send a crew out there and you remove the blockage from the drainage. So again, gray infrastructure, the maintenance associated with it tends to be well understood. All right. And so that's a plus. Oh, whoops. Let's see. And if you have big enough underground storage, you certainly are able to partially mitigate and sometimes completely mitigate flooding, as well as provide some pollutant removal benefit. All right. So those are things that gray infrastructure that we use are able to do. But let's talk now about some things that gray infrastructure tends not to be able to do in the world of stormwater. First of all, unless you're careful about where you put your great infrastructure, you will get nuisance flooding. All right. So you've done a nice job of clearing the water out from around the houses, but then all of a sudden it stops. And this is what you have when it rains 20 millimeters. All right. And that can be a problem. All right. Now, if you do a really good job of directing water away from higher areas, and then it stops in the low-lying areas, then guess what you have? Significant flooding. How many of you can relate to flooding like this? You've seen it before, right? Most places on Earth have dealt with flooding. I don't know. I should talk about Nigeria. Does Nigeria have a lot of flooding? I would guess you guys are pretty dry, but when it does rain, it's probably a big rain. Okay. I've gotten Omar's given a nod, so I'm with that. All right. Now, in addition to that, gray infrastructure tends to do a really efficient job. If it's moving water efficiently, it's also moving the pollutants that are in the water efficiently. And you can see a fair amount of sediment in that plume there. And sediment tends to be a bit of an issue. Now, one big problem we have in the United States with gray infrastructure is that it delivers the water so quickly to our streams that there's a lot of energy in that water, and we end up having what is referred to as in-stream erosion. All right. And this is somebody's house, this building right here. And this creek eroded so much that the person had to move. All right. And that's a problem when the infrastructure that we create has impacts on, I'll call them innocent people. They are innocent. They had nothing to do with all the gray infrastructure causing the erosion to this stream. All right. And so we are looking at gray infrastructure causing property value loss. Sometimes the gray infrastructure can be very frustrating because up here is your parking lot or car park. What do you, in India, do you call them car parks or parking lots? I know the Brits call them car parks. when you park a car, is it a parking lot? Is it a car park? You call them car parks? All right, I'll try to say car park for you. My shawl is falling off. You like just take it off? Okay, I'll leave my hat on. I love my shawl. I've ever been given a shawl. When I travel, I always try to buy gifts for the people in my life. All right, so that includes two daughters, and if I'm lucky, a very pretty girl that I'm dating, a very smart, sweet, pretty girl I'm dating. And so I buy shawls to give away as gifts, but this is the first time I've ever gotten one, so I'm very honored. It was great. All right, do I get to keep it? No? Oh, I hope I didn't breach some international etiquette there. Okay, I'm still going to keep the hat on for the rest of the day, therefore. All right, so we have a car park. The car park is next to the trees. What did the engineer do? He very efficiently designed the car park to bypass all the vegetation. Like that's how like in our head we go like, "Oh my gosh, we don't even think about the potential benefits that vegetation can provide us." All right. Sediment. I showed you a picture of it earlier. Here's a classic case of significant sediment. You can see the sediment laid filled creek and then creeks that don't have any sediment in them. Another unique pollutant to urban areas is everything that drains from our cars. All right. In America, this might sound crazy to some of you. Everybody has a car. I know my 17-year-old son has a car. All right. It's not a new car. All right. In fact, it's an old car. It's about 20 years old, which means it has vehicle leaks. All right. Well, guess what? When it rains, where does the chemicals from your vehicle leak go? To the stream. All right. So that's a pollutant we have to worry about that gets there because of our very efficient gray infrastructure. How about nutrients? Now, these pictures are actually from China, near Lake Taihu. And that's just massive amounts of nutrients. Nutrients tends to be a really big issue from agricultural areas, but nutrients are also in urban areas too. And so our urban areas contribute nutrients to our rivers. And if you have too many nutrients, nitrogen and phosphorus, it gets into the water column. And I know they didn't teach me this when I was a civil engineering student, but I've learned it. I've learned it since. Too much nitrogen and phosphorus, get a lot of algal blooms. The algae lives until it dies. When it dies, it sinks down to the bottom. Then it gets broken down by microbes. And what do those microbes need when they're eating the algae? They need oxygen from the water column. So what does that mean for the fish? Sorry, buddies, no oxygen for you. And this is what happens to them. They die. You want to get a bunch of Americans mad? Show them a bunch of dead fish. You guys like eating fish, right? How many of you come from a culture we like to eat fish? We eat fish. Yeah, we eat fish. One of my sons loves fishing. All right. Other issues. There's a lot of animals across the globe. There's a lot of dogs right here on the IIT campus, right? So because of that, there's animal waste. This is a picture from America. Same thing goes on there. And when you have animal waste, when it's located near where people are going to be, especially if it's near where people are going to be in water, then you run the risk of them getting sick. These pictures here I took when I was in New Zealand. All right. So again, it is a worldwide phenomena where we worry about pathogens in our stormwater runoff. And if you have too many pathogens, even if humans aren't going in it, that means you can't eat the shellfish and things like that. All right. So these are all issues associated with that gray infrastructure either do not help or make worse. So instead, let's think green. Let's talk about green infrastructure. I took this picture in Delhi a few years ago. It's kind of cool. All right. So when you're thinking green infrastructure, we're talking about green, clean, and smart cities, just like we have right here. We often think about keeping swaths of uh, parcels in green states. Okay, treed area, lawned area, areas that are peaceful and that are oases. Okay. You have one right here. This campus is an oasis in the heart of Rookie. And in the heart of the campus, in front of the Thompson building, that's an oasis. That's a form of green infrastructure. And I like to point out that even in really arid places, we like strive so hard to get green spaces. Do you know why? I'm not, this is my PhD is not in this part. That's not my stuff. But the reason is that humans love being around vegetation. Humans love being around water. You know why? We spend our first 9 months in it, right? A baby inside a mom, an in utero baby, is in fluid. We're in water. All right. So the idea of associating with nature, wanting to be with nature, is elementally human. All right. So as we go from green infrastructure, let's talk about how this now relates to stormwater. Okay. So stormwater practices are also green. Not all of them, but a lot of them are. All right. And therefore, they have little mini environments, little mini ecosystems sometimes. And then, so therefore, the use of stormwater ties in very nicely with green infrastructure. So we might refer to stormwater green infrastructure, ready for this, as green stormwater infrastructure. Okay. And we're going to spend some time talking about the benefits of green stormwater infrastructure. I'll hit a little bit here and then I'll close with some more. So this is an interesting situation. There is this Atlanta. How many of you are familiar with Atlanta, Georgia? Does the name ring a bell? The 1996 Olympics were held in Atlanta, Georgia. And at that time, how many of you, by show of hands, are graduate students? Do you have any graduate students in here? Just a few of you? I know some, I know you're a grad student. All right. Maybe you call yourself postgraduate students? Okay, that's what I should be saying, postgrads. So I was a postgrad, and the Olympics came to Atlanta. All right, I went to go see some of the Olympics. It was pretty cool. Hey, you know what's coming to the United States next year? The World Cup. Yeah, we'll talk. If you guys like soccer/football, we've got 4 days after this to talk about it. All right, you come tell me. You tell me who you think's going to win. Does Nigeria have a team? I bet DRC has a team. Okay, so the city of Atlanta had a big flooding problem. And this picture I showed you before, but this picture is actually from Atlanta. They had a choice. They could build big tunnels and store the water underground, all right? Or they could store it above ground and make an attractive spot for people. Guess which one they chose? Yeah, that's what they built instead of the big tunnels. Now we're gonna have a little vote here. All right, here it is. I want you to tell me which one of the two options was estimated to be more expensive, the big tunnels or the attractive green space. All right, how many of you think the big tunnels were the more expensive option? It's a lot of hands. It's near unanimity. How many are like, no, I think the green space? It's the big tunnels. Yeah, it was. The big tunnels are more expensive. All right. In fact, this is what might even be super amazing. In fact, the big tunnels were a factor of 5 to 6 more expensive. So there is an economic driver from a flood control perspective to try to employ green stormwater infrastructure. And they have walkways through the infrastructure here. They even have educational signs that will show you when the 100-year storm comes, this is how high the water will be inside our park. And of course, what happens if we get the 100-year storm? You're not going to use the park, but at least homes aren't being flooded. At least transportation corridors are not being flooded. All right. So I'm going to show you some pictures of this. They were given to me by the city of Atlanta. All right. So you're going to see as I flip through this, the pond, the big pond wetland thing being constructed. All right. Here it is. Here's the pond wetland being constructed. All right. It's going in. Oh, it looks pretty nice. It looks nice right there. Oh, they're putting something else in. Yeah. Well, there's the pond. Looks nice. Oh, they're building some more. They need to do a better job of keeping sediment on site. But there's our pond. They're still building. They're still building. And now here's our pond after all the construction. Here's green spaces associated with the pond. So again, green stormwater infrastructure. And now what I want to do in these red polygons, I'm going to show you new buildings that got built because, and the only reason they got built is because they were building this beautiful water feature in the heart of Atlanta. All right, there's Polygon 1, Polygon 2, there's the park, additional parkways got constructed, Polygon 3, 4, 5. Pretty cool, right? So the result of this pond being built essentially led to $500 million of redevelopment that the private sector decided to pitch in. So if you're a city and you're trying to encourage companies to move to your city, then I don't think 10 years ago, or certainly 20 years ago, people would have said, let's use urban stormwater management as a way to entice companies to locate to our city. But that is precisely what happened in Atlanta. So not only did it cost less, all right, to build it, but all the private investment enabled the city to have a higher tax base and actually make more money. So it ended up being a really clever move. Now let's see if this video works. This is a much smaller example. This is a project that we designed about 12 years ago. This picture was taken during the construction of it, and you'll see some permeable pavement. You'll see some bioretention. These are all different forms of green infrastructure being constructed. They did the right side as you look at it first, and they were actually doing the construction on the left side as this video was taken. All right, but this is a type of green stormwater infrastructure where you have made a streetscape a much more attractive place for businesses to then locate to. All right, I'll click through that. Now, I showed you some examples from the Southeast, but there are other places where green infrastructure has been used. In Los Angeles, they have these green alleys, these little alleys that people walk through, but as the water goes in, it soaks through, all right? And that helps keep homes from getting flooded. In Philadelphia, they had the same situation, and they found that it'd be a lot cheaper for them to build green infrastructure, $2.4 billion, compared to upsizing the gray infrastructure, which would have cost $8 billion. All right. And so if you start thinking about it, green stormwater infrastructure, once you've committed yourself to improving stormwater, the idea of using the green stuff actually tends to make the most financial sense. There are some issues that we can talk about offline about how this stuff gets paid for. And sometimes it is done by the private side. Sometimes it's done by the government. All right. So we talked briefly about climate change. One of the impacts of climate change is going to be the severity of storms. We have seen this happen in North Carolina. And as a matter of fact, we had a storm, I'm trying to get this right, that hit last year when we were up in New York City. It hit last year and it dumped, I want to get the exact right. In 3 days, it dumped 750 millimeters of rain in 3 days. I don't know about you, that's a lot of water. It's a lot of water. And it caused a shocking amount of flooding. A lot of people died in Western North Carolina. Well, those style rains are not unique anymore. They used to be unheard of. It used to be like 750 millimeters of rain in 3 days. Are you nuts? But no, it's not nuts. It happens now. All right. And we can associate that with the climate that we now live in. Well, Copenhagen had the same thing to deal with. They had this massive storm that caused flooding all throughout Copenhagen, Denmark, and they had the choice of either upsizing their gray infrastructure, basically making the pipes and the drainage ways bigger, all right? And that was going to cost something to the tune of about $3 billion, okay? Or the other choice was to make the existing gray infrastructure work better by introducing what we refer to as green stormwater infrastructure. The Europeans refer to it as SUDS, all right, sustainable urban drainage system, all right. In fact, the price for that was about 1/3 to 1/4 that it would have been to make the gray infrastructure upsized, all right. So what you're seeing, and a lot of you are going to graduate from IIT here and stay around here. Some are going to move to the big cities of India. Some are going to move to cities all across the globe. It doesn't matter where you're going, or if a lot of you are I need to ask, or engineers already. Doesn't matter where you're going. You are going to be dealing with these big storms, and the question is do you try to make your existing infrastructure sufficiently big, or do you instead try to put sponges in on the landscape to hold the water and then slowly release it? In fact, the term the Chinese use for green stormwater infrastructure is sponge cities. It's a very clever term, and I like it. So here's a case in Denmark where they were retrofitting. So just remember that green infrastructure, which is generally vegetation based, vegetation and soils based, when you install it, it provides storage capacity to help the rest of your infrastructure, the gray stuff, work better during big storms. All right. So how hard is it to go from gray infrastructure to green? Well, don't get scared. This is not terribly hard. Sometimes it is. Sometimes it's very easy. Uh, we were driving up from Delhi. How many of you drive here in India? You're brave. You guys, you're brave souls. How many of you drive in Delhi? You're crazy, actually. That's beyond brave. No, it's good. I drive just about wherever I go, but I haven't decided I can do India yet. I haven't. I was in Tunisia. I was loving it. Je parle français un peu, enough that I can understand the signs. I'm doing fine down there. I'm driven to Morocco. I drove in Italy. Dude, I don't think I can I don't think I can do India. But you know what? You guys got good drivers that, you know, just let's just ride with them, right? Anyway, on our drive up from Delhi yesterday, what I saw a lot of infrastructure getting built. All right, a lot of railways and roads. Okay. One of the ways that you can help roadways be treated is literally to have the roadway runoff flow over green. That's it. I hate to say it's not that hard. It's not that hard. Now, not every opportunity allows that, and you do have to provide enough space along your roadway to make that happen. But that is a way that you can treat your gray infrastructure. And you can see other examples of it here. If you want to learn more about that, you certainly can. I'm going to blow through this. Okay. I thought I had hidden those, and I apologize for not doing that. So when we talk about green stormwater infrastructure, what are the practices that we're generally referring to? All right. So I'm going to share with you some pictures, and a lot of these we're going to spend some time on going forward. All right. So dry ponds. They are ponds. I know this sounds kind of crazy. They are ponds that tend to be dry unless it's raining. And so up here, we have a 4-month monsoon. They would tend to be quite dry for probably 7 to 8 of those months and have water in them for 4 to 5 of those months. That's a dry pond. We'll talk more about the design of those later. Then there's the cousin of the dry pond, the wet pond. And so my buddy and I were going to go down to Kerala. I think it rains a lot in Kerala. All right. Their ponds are probably going to stay wet. Some of them can be designed to be quite beautiful, like this one. Um, some of them are designed to look like this. That's not so beautiful. All right. This is the norm. This is what we normally see. All right. That's the exception. That's beautiful. That's the norm. All right. Then we've got a practice called constructed stormwater wetlands. All right. And it is what they sound like. They're wetlands that we design and build. All right. And they're also able to treat stormwater runoff and reduce flooding. Here's an example of one that we installed at a school, a secondary school, not far from NC State. And it became a classroom. That is a young version of me right there. That's been a while. And here we are taking students into the class, and we're not gonna walk you into wetlands as part of this course, but we are going to identify where they could go. All right, and that's going to be one of our activities that we'll be doing on Thursday, and we're very excited about that. Another practice that is out there is called bioretention. Other folks will call them permeable streetscapes. Others call them rain gardens. All right, but they're a very attractive practice. We're going to spend some time talking about them. But here is a grass version during a storm where the water fills up and is temporarily held. All right, and in doing so, the water is able to get treated. Tomorrow, the first lecture I give tomorrow is a discussion. I think it's tomorrow. Is a discussion on the different types of pollutant treatment mechanisms that are employed in green stormwater infrastructure. All right. Here's one where it's literally right smack dab in the heart of a city next to some car parks. And I'll talk more about this when we get to it, but they improve hydrology. Then we have systems called infiltration basins. And infiltration basins work great if your soils are sufficiently sandy or sufficiently permeable and the water table is not close to the surface. And they're very simple to design. I had a team of seniors do this in college, and they did a great job and actually watched it get built. But here it is during a 75 millimeter rain. It's just filled up, and here it was the next day. And that water, all it's done is just soak into the ground. All right. So that's a pretty simple system, and it looks pretty good too. Is anyone here that's a landscape architect? Do we have any architects or landscape architects? That's okay. When I teach workshops in North Carolina, we tend not to have many, but we'll have a few. The reason I bring this up is engineers, and I'm an engineer, we focus on making sure that things work right. Isn't that what we do? We're trained to make things work right. All right. I don't know any of you, you should ask your spouse or your girlfriend if they get or boyfriend if they get tired of dating an engineer because whenever she or he has a problem, you're there to try to fix it, right? You know what I'm talking about? You're always trying to fix it. Oh, I can fix that. And I've learned the hard way because I've had them tell me, Bill, I just want you to hear me. I don't want you to fix it. Just hear me and agree with me. So I'm getting better. I'm 53 and I'm still trying to learn these important life lessons. Okay. But we can fix things. We're good at fixing things, but that doesn't mean we're good at making those things look good. All right. Engineers were not trained to make things look good. All right. I have learned a little bit, but I've also been working for 28 years in the field. All right. But I've learned a little bit, but I have also learned that if I want something to look good, I'm going to try to bring in a landscape architect. You know what they're good at? Making things look good. All right. Just remember that. Well, here's why it's important. If it looks good, guess what? You're more apt to take care of it. Did you guys know that? If it looks good, how many of you have ever gotten a new car? You're like, oh, don't drink tea in my car, you know, then it gets spilled. Now, if you had the car for 5 years, people are snacking inside, you don't care, right? But when it's new or it looks good, you tend to be very, very protective. You tend to take care of it. Well, we need to do more of that in the world of engineering. This is a rather simple practice, but like filters where water just flows across grass. Believe it or not, that works at taking pollutants out. This might not do a lot for flood mitigation, but it's pretty good for water quality improvement. Now, we're going to spend a lot of time. Venerosity, is tomorrow Swales Day or is Wednesday Swales Day? Wednesday is Swales Day. So tomorrow is Rainwater Harvesting Day. Great. We're going to talk about swales a lot on Wednesday. Why? Because they're everywhere. All right. And we can use swales. This picture here comes from New Zealand. I've seen swales pretty much anywhere I've ever been. Now, some of them work better than others. All right. Some of them look better than others, but swales are used all over the place. There's some big fancy swales out there. That's what this is. They call them regenerative stormwater conveyance. Fancy name for it. Whoop. Wait a second, I'm going the wrong way here. I have my mouse is more sensitive to my finger. My finger is not very good. Now, permeable pavement is what it sounds like. As I walk through IIT Rookie, guess what? I saw lots of places where you might be able to use permeable pavement. I was pretty excited about that. Here's an example of a car park in Western North Carolina in our 2,000-meter mountains. All right. And permeable pavement is exactly like it sounds. Water soaks through it. We're going to talk about that one on Friday. All right. We'll talk a little bit about green roofs on Friday too. I can think of a couple places on campus where maybe a green roof would work. We'll have a very short discussion on that at the time comes. Here's NC State, where how many of you guys like basketball? Are any basketball fans? Let me ask you this. How many of you know who Michael Jordan is? Okay, that's a lot better. Did you know that Michael Jordan grew up an NC State fan? He did. But he went to our rival school called UNC Chapel Hill. But Michael Jordan grew up an NC State fan. I regret that he did not go to NC State because all of you would know about the Wolfpack if he had. Okay, rainwater harvesting. Rainwater harvesting, capturing water from rooftops, sometimes other landscapes, and using them for other reasons. Lots of examples of that. In fact, when I was in India last year, I saw some really cool examples of ancient rainwater harvesting. We're basically making rainwater harvesting great again. That's my goal in the world of rainwater harvesting. All right. And then there's also very simple systems that you can put in the ground that are prefabricated that help trap sediment and debris and stuff like that. But they do require maintenance, which is something that you are already contending with in front of the monsoon season. All right. So I've just gone through a list of a number of the stormwater practices that are used to help reduce flooding and improve water quality. We will spend a fair amount of time discussing most of what I just went through over the course of the next 4 days. Not all of them, but we'll spend some time on most of them. Now, this green infrastructure provides things called ecosystem services. How many of you have heard the term ecosystem services? All right. The next part of this talk gets into ecosystem services. And essentially what it is are things that ecosystems give us for free. Okay? They give it to you for free. So a big wetland, for example, that will tend to improve air quality. All right, a healthy ecosystem will tend to have improved air quality, removing particulates. All right, if it's heavily vegetated, you tend to keep your temperatures lower. All right, so a lot of ecosystems provide food. All right, certainly for animals and often for us. Then you can have other things. Obviously, in India, flowers are really important. Do you know? And I love that. I love flowers. I'll talk about them a little bit later in this lecture. But you know, you can design stormwater control measures so that you can grow and harvest flowers. That's pretty nice. They can look good. They can be used for education purposes. And you can also use them, like I showed you before, there's a path to walk for recreation. All of things put together make property more valuable if you can design your green stormwater infrastructure to look good. All right. Now, I'm going to spend some time talking about green infrastructure now in this next piece of the lecture, because when you put stormwater in the ground, the value of the infrastructure, the green stormwater infrastructure, goes up, the more benefits that the green infrastructure gives you. Okay. So we're going to talk about those benefits now between now and the time that we take our next break. So let's think about some ecosystems that are out there. I'm going to start off with this one taken from the Red Fort down in Agra. That would be a semi-arid river floodplain ecosystem. Okay. Can you guys think of any ecosystems associated with where you come from? How many of you come from a place where it rains 1,800 millimeters, 2,000 millimeters a year? Charles, where about you? How much does it rain where you come from? Okay. Well, when I think of the Democratic Republic of Congo, I think of a lot of rain. I could be wrong, but I don't know. All right. But if I think of the heart of Africa, I think about so much rain, or I think about South Africa, I think so much rain that you have a jungle ecosystem. Okay. There are grassland ecosystems. There are lots of different I mean, all ecosystems have, almost all of them have water. But tidal marshes, very popular. So when I leave next week, I'm going to take a couple of days to go to Kerala and do the backwaters, right? Well, that's a special ecosystem that's unique to India, right? There's mountain ecosystems. That's my youngest daughter. She's gotten a lot bigger since then, but where waterfalls, and then we have even urban ecosystems. They're not quite as nice, but they are ecosystems, all right? And they do provide benefits to us. And so the idea behind ecosystems is that they have services, okay, things that they deliver, and when we get the benefits of those ecosystems, those are specifically called ecosystem services. Now, I operated the first, I don't know, 12 to 15 years of my career without really thinking about ecosystem services. For the last 12 to 15 years of my career, I think about ecosystem services a lot. And it's all because when you're trying to promote the use of a new infrastructure, which in part you'd be doing here, right? You need to come up with as many reasons why you should use it as possible. Maybe flood mitigation is enough, all right? Maybe, that's fine. Maybe improving water quality is enough. But if you can also tell developers, hey, if you do this, your property values will be higher. Ooh, they might like that. Hey, if you do this, you might be able to lower your heating, well, not here, your cooling bill. Okay. Ooh, that sounds good, right? So being able to put these benefits together and start stacking them up, that's a way that people want to pick innovative stormwater. Oh, I think I mashed the wrong button. Okay, no, we're good. We're good. So here's a list ecosystems. All right, waste treatment, hydrologic regulation, erosion control. Doesn't that sound like stuff that we might worry about in the realm of stormwater? And does food production and recreation, those things we might not think about stormwater, but the reality is our green stormwater infrastructure can do those things too. And importantly, all of these things have value. Okay, they're all worth something. Now, whether or not that value has been quantified is a different story. All right, But all these things have value. And as I said before, a lot of what we construct actually are little ecosystems. So when we build green stormwater infrastructure, we usually think of two specific ecosystem services. One, we want hydrologic regulation. We want flooding to be reduced. All right. And two, we want water treatment. You might also throw in erosion control. You might also throw in nutrient management. They all relate, nutrient cycling, they all relate. But we basically put our green stormwater infrastructure in for these two ecosystem services. But the reality is that list of what they can provide is a lot longer. Now, I only have 1 week with you. And so as a result, I'm not going to get into detail on most of these other potential benefits, but I will spend a little bit of time on Thursday talking about carbon sequestration and the role that stormwater practices have in the realm of carbon sequestration. But just but in the next like 20 minutes, I will pop through all these other potential benefits. So flooding, we put stormwater control measures in because we want to reduce flooding. All right, flooding is a worldwide phenomena, and this is what drove the use of sponge cities in China. Okay, now sediment erosion control. I talked about this particular earlier. If you're not careful with erosion control, you have property loss, and that can do significant damage or ruin structures. And certainly we don't want our structures. I know that IIT Civil Engineering has a very good structural engineering program. Look, those structural engineers, they don't want to see a bunch of water running past the foundations of their buildings. Now, one of the ways that you can improve hydrologic mitigation and reduce flooding is by not discharging a lot of water. So I'm going to show you a combination green-gray site, because I think most of the time, especially I think in India, but even in the United States, when we put in a stormwater management practice or set of practices, it's going to be a combination of gray infrastructure and green infrastructure. Okay. So at this site, we had two places across the street from each other. One was a low impact development site that had a lot of green infrastructure. The second one was a development site that didn't have as much. All right. And what we wanted to see was how much runoff could be reduced by using stormwater control measures. The city of Raleigh, let me ask you, I don't know the answer for here, which bugs me, but maybe somebody does, but I can tell you the answer. How much of the rain, we get 1,100 millimeters of rain a year in Raleigh, North Carolina on average. Someone shout out, not someone offer up, you can shout it out. How much of that do you think runs off a naturally occurring like park or the woods? How much of 1,100 millimeters do you think runs off in a natural area over the course of a year? What do you guys think? I know it's just our first day together. Oh, they're recording it. Believe it or not, I tend not to like to stand. I should have told you this. I like to move around, but if we're recording, I got to be careful. Do you have a mobile lapel mic for not today, not right now, but maybe later? Yeah. Okay, that'd be great. We'll do that tomorrow. Oh yeah, maybe even right now. So yeah, I like to move around. I like to actually come out and see you guys. Get ready. Omar, you might want to, I don't know if I'm gonna be there. You might want to move. I don't know, I might get too close to you. I don't know. All right. So what I'll do is I'll just give you guys three choices. All right. And a natural condition. So think about it like a park. All right. With trees in it. It rains 1,100 millimeters over the course of a year. Do 100 millimeters runoff? Do 250 millimeters runoff? Or do 500 millimeters runoff? All right. Is it 100, 250, or 500 out of a total of 1,100 millimeters? All right, how many of you? So we're going to have a vote. How many of you say 100 millimeters runs off over the course of a year from a park? All right. Appreciate your optimism there. Anyone else optimistic? Okay. How many are like 250? 250. People like to pick the middle one. I know. How many are 500? A lot of pessimists here. Okay. My friend with the beard, what's your name? I'm going to have to get over there. I don't hear. But Akeem is correct. 100 millimeters. That's right. Akeem, where are you from? Okay, but you're at IIT Bombay. A lot of good architecture down in Bombay. Famous for that. Okay, nicely done. That's exactly right. 100. And so when they built, thank you so much. This is great. If I roam around, is it going to be a problem? All right. What I want to do. What I want to flip it like that. This is great. You guys have just unleashed a tiger, because I'm coming for you. All right. Thank you so much. You know, I got it from there. That's perfect. I'll just slide it in here. I feel like James Bond. No, 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 no. Okay, great. All right, so what the city of Raleigh said is they're like, look, we'll let you build this shopping center as long as you don't release more than 100 millimeters equivalent of runoff a year from an 1,100 millimeters worth of rain. Now, that's pretty tough, right? You think about how much it runs off, get 1,200 a year here. I wouldn't be surprised if you have 600, 700, 800 actually run off a standard development here in Rookie. All right. So what ended up happening is the company came to NC State and they're like, hey, we think we designed a system that will meet this requirement. But the city of Raleigh has made us say that we have to test it. Would you test it for us? You know what my answer was? Sure, I'll test that. That sounds like fun. And so the fancy site that they laid out had bioretention. You can see some example here, a grassed area where water can pond, all right? It had some swales. We talked about those before. It also had a really big infiltration system, and it had rainwater, and it had rainwater harvesting. I don't have a picture of it in there, but it had rainwater harvesting, all right? So we have a combination of green infrastructure and gray infrastructure. All right. Now, across the street, they had a dry pond and some conveyance. So not as fancy. So but they still had some. And so the runoff coefficient is a measure of how much water runs off compared to that which falls from the sky. Okay? It's pretty simple. It's pretty simple. It's literally how much water ran off over the course of a year relative to the amount that could have run off. All right? And the standard site that had a dry pond, about 50% of the drops ran off. That's pretty normal. All right? For our low impact development site, 2. So the site that had the bioretention, the swales, the rainwater harvesting, the underground infiltration chambers, 2%. What is it normally? Between 5 and 10%. So in this particular case, the engineering actually did better than Mother Nature. Then you're like, dude, how did that happen? How do you do better than Mother Nature? You know what Mother Nature doesn't have? 2 meters of driving head. Right? When it rains, we don't develop 2 meters of driving head. But in those big concrete boxes that were infiltration chambers, they could pond up to 2 meters of driving head. I do use English units. I do use imperial units. I do the best I can with you, though. I promise. All right. So hopefully everyone's like, I get it. Combinations of green and gray infrastructure are able to reduce flooding. Now, they did have to spend more money to make it get there. What about for nutrients? I'm going to spend a lot of time talking about nutrients. One of the things that we did is when we built constructed stormwater wetlands, so any green stormwater infrastructure that we build tends to have a cognate, naturally occurring ecosystem. All right. Now, the easiest one of those to relate to is the stormwater constructed wetland or the constructed stormwater wetland. What naturally occurring ecosystem do you think we as designers look to for design inspiration? What type of ecosystem? Do you think we look at a stream, at a desert? If you're building a stormwater constructed wetland, guess what naturally occurring ecosystem we look to for inspiration? The answer to that question, it's going to come as a shock to you, is a wetland. You're 2 for 2. You're repping IIT Bombay really well today. All right. Yeah. Say we look at naturally occurring wetlands and we try to model our designs on that. That's what ecological engineers do. And that's what my career has kind of evolved to being, is something called an ecological engineer. I still definitely have a big foot in the CE water resources realm, all right, without any question. But we do a lot of stuff in this realm of ecological engineering now. All right. And so what we did is we looked at 7 different stormwater wetlands, and we compared the outflow concentrations leaving our stormwater wetlands, which again are inspired by naturally occurring wetlands, and we compared those nutrient effluent concentrations to a reference naturally occurring wetland to see how similar they were, okay? All of this was in North Carolina, all right? So the same type of plants are being used and the like. And essentially what we found, if you look at all these plus signs right in here, you see that? That is the naturally occurring wetland organic nitrogen concentration. And you can see that for 6 of the 7 human-built, designed and built wetlands, 6 of the 7 were pretty close, which is great, right? That we're putting man-made practices in the ground that are modeled on naturally occurring practices and getting not the exact same result, but getting a very similar result. And that, my friends, makes an ecological engineer feel really good. I feel like we've done at least an okay job. All right. Now let's talk a little bit more about other pollutants that our green infrastructure can treat. We have had rivers catch on fire in America. For anyone, I know a number of y'all have been to Germany. Germany, the Ruhr Valley was dead for a long time. It isn't anymore. All right. So polluted streams, and I was talking before about very polluted rivers here in India, this drive to clean them up. We've dealt with that. We deal with that. All right. This is again in Cleveland where LeBron James grew up. Okay. Making it all about basketball today, apparently. And I went ahead and got some data from one of my buddies at the University of Maryland. And what he shows you here in this pie chart is all the pollution that came into the bioretention cells. And everything that's green is the pollutant that got retained in the soil. Everything that's, I don't know, magenta or red, that's the pollutant that went up into the plants. And all the blue
That's the pollutant that left. So what do you see here? And you don't even have to be a research engineer to figure this one out. Where do most of the pollutants go? Into the soil, right? And very little pollutant actually left, which meant that these stormwater devices were keeping all of this pollution out of the river, of the creek, which fed a river. All right. So hopefully through a couple of these examples, and I will show you some research because I do that. That's a big part of my job. But hopefully through these examples, you guys are on board with me when I say that stormwater control measures do a good job, or can do a good job if designed right, of reducing flooding and taking pollutants out. All right? But then I'm going to tell you something right now that kind of shoots it in the foot. And it is, aren't they supposed to? Right? That's what we're putting them in for. We're putting stormwater practices in to reduce flooding and to improve water. If we didn't do those things, then we wouldn't be having this workshop this week, right? But remember, when I started this second part of the presentation, I said we need to start stacking up the benefits to try to make people want to use this infrastructure, want to spend the money for this infrastructure. So let's not limit our returns to only runoff mitigation and water quality improvement. So this was an executive order that the President of the United States, I'll let you guess who the president was in a second, said that all our federal agencies need to make sure that we're reducing greenhouse gas emissions, blah, 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 all the way to stormwater management. So this particular president related greenhouse gas and stormwater management. I'll give you two choices. Was this President Obama or President Trump? This was Obama. This is President Obama. That's right. So he's like, you got greenhouse gas. What can you do in the world of stormwater to reduce greenhouse gas? All right. Well, we did some studies and we looked at that answer, and we'll spend a lot of time on this on Thursday. Okay. But I want to point out that there are certain practices, especially wetlands, that if you give them enough time, they can become carbon sinks, all right, as a way to help mitigate some of our greenhouse gas emissions, all right? And that was not something that when I went through school, anybody worried about. Nobody worried about how's your stormwater practice reducing carbon. No one cared about that. They cared about flooding. That was pretty much about it. All right. So this is a potential benefit to add on. On Thursday, we will demonstrate how to predict that by using a model that my buddy who was up here is associated with. But we'll worry about that. I mentioned heat island. Another one of my former students took a look at the temperature within a city. All right. Knoxville, Tennessee. Not a big city, but a city nonetheless. And what he found was that if you, the closer a house was to land cover, all right, meaning more trees, the cooler it was. How many of you are surprised by that? In fact, if you were surrounded by a bunch of impervious surface and didn't have any trees versus being near quite a few trees, this was a 2.2 degrees C improvement. Does that have value? I don't know exactly how to quantify that value, but I do know that the cooler it is at night, the better I sleep. And the better I sleep, the more productive I am the next day. All right? So all of you need to pray that I get over my jet lag as soon as possible. I'm doing fine. Hey, you guys like my new shoes? My kids do. They're like, Dad, you're going to wear those to India? I said, I sure am. You know what they said? Dad, that's fire. That's American English for cool. Dude, Dad, that's fire. I'm like, oh, yeah. Your dad, full of fire. All right. How many of you ever think about biodiversity? Yeah, that was my response as an engineering student. I never worried about biodiversity. Guess what? As an ecological engineer, I need to worry about biodiversity. Okay? So much so, particularly for larger basin systems, it's particularly important. All right? And so, without getting into what the details are here, we found that you can have a pond that doesn't have any vegetation and have a pond that does have vegetation, and the pond with the vegetation has a large fraction of predators. What do you think those predators are preying upon? We're not talking about snakes here either. These are insects. What do you think predator insects, what other insect do you think predator insects are preying upon? And it's one that is responsible for a lot of human deaths globally. Like, what's the worst insect you can imagine from a human health and life perspective? You're saying it. Mosquitoes. Mosquitoes. So let me ask you this. If you knew there was a way that you could design a stormwater control measure that attracted insects that like to eat mosquitoes, would you do it? If you could design a stormwater control measure with features in it that helped attract mosquito predators, would you not include them? And the answer is, yeah, we would. All right. And so because of this study and another one that's related, there's certain elements of how we design wet ponds now that are specifically designed with wetland areas around them that help keep mosquito populations down. Because that's always going to be a danger if you pond water and have water on the surface for a long period of time, all right, which is pretty cool. So again, we actually design our stormwater control measures based on biodiversity, because by having biodiverse ecosystems, we're far less likely to have mosquito dominated. Doesn't mean they're not present, but mosquito dominated stormwater. We do not want mosquito dominant stormwater systems because no one's going to want that. They're going to be afraid of it. There are recreational benefits associated with these things, educational benefits. Remember when I said you should always get a landscape architect involved? If it is a public facing, meaning that people are going to be interacting with it or going to see it, you want to make it so that they can learn from it and it's attractive and they're going to like it. All right. Again, if you do that, it means they're more likely to take care. Now, we like having urban oases. I mentioned that before. That area, just Thompsonville, I think it's just right over there, right? Is a beautiful oasis right here. What if you made your oasis a stormwater site? This is in LA. It's pretty nice. Oh, we're almost done. Almost done. Almost done. I'm going to skip through those things. I'm so sorry, guys. Flowers. We're almost done. We're almost done. I apologize. I was so excited. Okay. You're very kind. I'm almost done. Green roofs. Green roofs have this possibility of actually growing food on them. Okay? There is a hotel in Canada where they grow produce and herbs on their roof. And they claim that they save 30,000 Canadian dollars a year by growing things on the roof rather than buying them and bringing them into Vancouver. Now, whether or not, oh, I think that probably is true. I'm going to tell you why. The reason I think it's true is because they're building a new hotel and they're adding a green roof for the exact same reason in Eastern Canada. So if they weren't making money, saving money, then why would they do that? All right. So to sum it all up, there's a bunch of other benefits that are provided by well-designed stormwater practices, okay, that make those practices even more beneficial to investors, meaning they can make more money from them. And by doing that, we tend to get the best types of stormwater practices in the ground. And so my question for you to close this lecture is, if we make our stormwater control measures to have more stuff, reducing flows, improving water quality, looking good, improving property values, reducing carbon, adding recreational fish, who's the beneficiary of all those things? Us and the environment, but us. Hopefully y'all now have a good feel for why I'm so excited about stormwater in the future, and I hope all of you feel that way as well. Thank you so much for this paying attention during this first lecture. And again, it is great to be in Rookie, and I know we have a tea coming, and I'll see y'all during the break. Thank you.